This tutorial, we're going to be solving two problems that are actually related to the gas stoichiometry questions. Okay, let's look at this first one. It says in the following reaction, we have 4.2 liters of O2 gas produced at 790 mm of mercury and 30 degrees Celsius. How much silver oxide have been decomposed? So when this reaction is actually given, you want to make sure it's balanced, and it seems like it's not balanced. So to balance this, focus on maybe the biggest subscript. One of the biggest subscript is going to be the oxygen on the product side. So we got 2 there. So maybe go ahead and put 2 in front of Ag2O, and that makes 4 oxygens, 4 silvers rather. And then you want to go ahead and put 4 on the silver side on the product. So this silver oxide is actually a solid, so that's why it's decomposing and it's making silver. That's going to be solid, and your O2 is going to be in a gas. So the question tells us when you do this reaction, you're producing this much gas, and they don't give you the mass of the gas, but they actually gave you the pressure, volume, and the temperature of the gas. So I would say this information pertains to the oxygen. So I'm given the volume to be 4.2 liters, and I'm given the pressure to be 790 mm of mercury, and I'm also given the temperature to be 30 degrees Celsius. Now, if you recall, in any stoichiometry problem, your central point has been the moles. If you know the mole of the reactants, you can figure out the moles of the products and vice versa. So your job is to figure out the silver oxide eventually, but if you know the moles of oxygen that has been produced in this reaction, it's going to be an easy task after that to figure out the moles of Ag2O and then eventually the mass of Ag2. Oh, okay, so then let's see how we can figure out the moles of this oxygen. Well, I know the volume, I know the pressure, and I know the temperature, so I should be able to use this PB equals nRT equation. Okay, so that will find you the moles, so it's going to be PB over RT. You just have to make sure your units are correct in when you're using the R. So your pressure, which is 790 mm of mercury, so I want to make sure to convert that to atmosphere. So 1 atmosphere is going to be 760 mm of mercury. So whatever comes out there. And then for the temperature, I have to add up 273 to that. So that's going to be 303 Kelvin. Okay, so let's see what that pressure is. So I got 790 divided by 760, so it's 1.04. So I'll just kind of write down on the left side here. So 1.04 atmosphere. Your volume is 4.2 liters. And then you divide that by the R, which is going to be 0.0821 atmosphere liters divided by moles Kelvin, and then times your temperature, which is 303 Kelvin. So all the units will cancel out here. The ATM goes away, the liter goes away, Kelvin goes away, and then you're left out with the moles. Okay, so when I do this math, I got 1.04 times 4.2 and divide that by 0.0821 times 303. That gives you 0.176 moles of O2. Okay, so if I know the moles of O2, I should be able to figure out the moles of Ag2O used in this particular reaction. So set up in a stoichiometry relation here. So 0.176 moles of O2, and then I would have I can find out the moles of Ag2O, and I can get rid of the moles of O2, and I know for every mole of O2 there are 2 moles of Ag2O used, silver oxide. So I got 1 mole of O2 and 2 moles of Ag2O. And then it's asking how much it's used, how much is decomposed. So I want to make sure I get the molar mass of Ag2O. So go ahead and figure out the molar mass of Ag2O to convert it to the grams. So grams of Ag2O goes on the top, and then moles of silver oxide will be on the bottom. So 1 goes with the moles, and let's see what the molar mass is going to be for silver oxide. So make sure you add up. Okay, the molar mass of silver oxide is 231.7. So make sure you get that correctly. Your moles of O2 cancels out, your moles of Ag2 cancels out, silver oxide cancels out, and you're left out with the grams of silver oxide. So when you do this math here, got 0.176 times 2 times 231.7. So that comes out to be 81.5 grams of silver oxide to be decomposed in this particular reaction. Okay, so that's how you're going to be doing this particular stoichiometry problem. Let's look at another one. Let's say I have this problem that says write an balanced chemical equation for the combustion of methane to form carbon dioxide and water. And they don't really give you the formula of methane, but in the real question they may give you that unless you're taking an organic. In that case, you expect to know that. So methane is being burned in the presence of oxygen, and it's making carbon dioxide and water. Make sure you balance this equation. Okay, seems like I need 4 hydrogens on the product side, so I'll go ahead and put 2 there. Your oxygen becomes 4 on the product side, so I need to put 2 in front of the O2, and that should take care of this problem. Everything seems to be balanced now. So now the second part of the question says if the methane has a volume of, probably just if methane has the volume of 0.65 liters when under 100 kilopascals of pressure and at a temperature of 305, find the mass of oxygen that's needed to use up all the methane. So it's like, you got 2 reactants and I'm trying to burn all this methane, but I got to figure out how much oxygen would I need in order to burn all that methane. Okay, so like I said earlier, if you know the moles of the reactant, you can relate the moles of that reactant with the other reactants or even with the products. And that's exactly what we need to do. If somehow you can figure out the moles of methane, you should be able to figure out the moles of oxygen and proceed from there. Now, the information I have about methane, so I'm just going to write that down here, is going to be the volume is 0.65 liters. I have the pressure to be 100 kilopascals, which is going to be 100,000 because kilo is just a thousand. And then the temperature is given to be 305 Kelvin. Okay, I have 3 sets of variables, so that means I can go ahead and use PB equals nRT and find the moles there. So your moles is going to be equal to PB over RT. So your pressure, well, I need the pressure in atmosphere because you're using R. So make sure you convert this pressure to the atmosphere. What's the relation between atmosphere and Pascal? 1 atmosphere is 101,325 pascals. Okay, so your pascals cancels out. So you do this math. It's got 100,000 divided by 101,325. So that's about 0.99 atmosphere. So I'll just go ahead and plug those values in. I'm not going to write down the units here. So pressure is going to be 0.99. Your volume is going to be 0.65. And then your R is 0.0821 temperature is 305. So then the moles is 0.99 times 0.65 divided by 0.0821 times 305. It's going to be 0.026 moles of CH4 being burned in this particular case. So I can go and set up the stoichiometry relation here. So starting out with the moles of CH4, so we got 0.026 moles of CH4, and then go ahead and find the moles of oxygen here. And if I go back and look up the stoichiometry relation, for every 1 mole of CH4, you are producing 2 moles of oxygen. So I'll go ahead and write down 1 mole of CH4 in the denominator and 2 moles of O2 on the numerator. So that way the moles of CH4 cancels out. And we are actually trying to figure out the mass of oxygen. If you were trying to figure out the moles, then you would just stop here. But since you're trying to figure out the mass of the oxygen, I would convert that moles to the grams of oxygen. So I'll have grams of O2 on the top there and moles of O2 on the bottom. So then I will go ahead and use the molar mass. So 1 mole of O2 is going to be the molar mass of O2, which is about 32 grams. So moles of O2 also cancels out. So at the end of the day, when you do this math, it's going to be 0.026 times 2 times 32. So it comes out to be 1.66 grams of oxygen to be needed in that particular reaction. So you would need about 1.7 grams of oxygen to make sure you use up all the methane that's provided in the question. So if you have any confusion on this, if you have any problem with this, feel free to leave any comments in the section.